This is the flood lighting design of the Belvedere Palace in Warsaw. It was developed based on a full 3D model. The task of a lighting designer is to meet the principles of object flood lighting as well as recommendations and standards. They refer to the average luminance levels on an object. Computer software makes this possible. This is done based on false color images. Through this picture, you can see how difficult this task is. Please stop this video and try to assess the average luminance level for this object. Soon, you will know whether you made a mistake in your assessment and, if so, how much. But now let's use the ELumCal software to do it precisely. You can load the luminance or illuminance distribution made by any computer software. In our case, you should crop it appropriately. This can be done both on the right and left side. You should also define the legend. In our case, it is vertical, so its selection window should be rotated 90 degrees. Using the window, select the legend area. The software automatically removes black and white colors from the false color image. It is also possible to select any color and specify the tolerance. This way, we remove areas of this color. In our case, this color also defines some parts of the object. You can correct this by selecting these areas and excluding them from the filter masks. You can also perform this correction in the indexed image window. Here, you can additionally mask any areas from the image. In our case, the substrate should not be analyzed. By creating any shape, you can define its surface area. ELumCal will calculate the surface area's total value by specifying the size of the selected shape. Pressing the lock button will allow this value to be used in utilization calculations. You can activate lighting analysis both in the View section and in the top bar. You can easily change the background of the interface. It is necessary to define the display type of distribution. You also need to decide whether it is illuminance or illuminance distribution. The next step is to enter the range. In our case, it is illuminance distribution ranging from 0 to 30 candela per square meter. ELumCal will instantly calculate the average luminance value over the entire object. It will also provide the minimum, maximum and uniformity values. As you can see, the average luminance value is almost 9 candela per square meter. I'm curious about what value you bet at the beginning of this tutorial. You can still modify the masks if necessary. You can create any shape of measurement mask area. So let's check what parameters characterize the luminance distribution of the central part of the Belvedere Palace. The average luminance value is 12 candela per square meter. The software also allows light meter. Based on the previously defined surface area, ELumCal calculates the dimensions of the selected measurement field. You can decide at how many points the measurement is performed. Measuring points can be both in the center of the matrix and at their vertices. Based on them, ELumCal provides calculation results. All point values can be exported to a CSV file. The analysis can also be performed based on a histogram. You will check how large surfaces with specific luminance values are. Just move your mouse cursor to any peak. Using the left and right sliders, you can define the threshold below or above which values will be removed from the luminance distribution. You can check which parts of the luminance distribution have not been taken into account. You can turn any peaks on and off by clicking on them. Finally, utilization can be calculated. To switch between windows, use the top bar or the View section. First, you can check how well you met your assumptions about the average luminance level. Assumed luminance for this project was 6 candela per square meter. The lighting design is oversized. This can be checked both without and with an interval using a histogram. In conclusion, electricity consumption will be greater than necessary. Knowing the average reflectance of the object, its surface area, and the total luminous flux of the light sources, you will find out the floodlighting utilization factor, both on an object without and with the use of a luminance interval. By entering the luminous flux of all luminaires, you will know what the maximum floodlighting utilization factor is for this project, and coefficient of floodlighting utilization factor. Using the ELumCal software, you can analyze the lighting of interiors, roads, and even light sources. The software also works well with real objects. This is a Frederick Chopin monument. By scanning this object, for example using the photogrammetric method, we obtain a material bitmap, which can be loaded. As in the case of lighting analysis, we can remove the background, black, white or any other. In our case, the background is black. You can define areas that will not be filtered and which are to be removed. Knowing the average reflectance of any area, we should check if software calculates the same value. Let's say it should be 0.27. It's not. So, we use the reflectance factor multiplier. The software will calculate the average, minimum and maximum reflection factors for the Frederick Chopin Monument. Let's say we want to renovate a monument and find out how much building material is needed to carry it out. You need to mark the area whose surface is known. Let's say it is 5 square meters. The total surface area of the monument is 396 square meters. All results calculated in the ELumCal software, both lighting and non-lighting, are included in the final report. Thank you for watching. Enjoy working with ELumCal.